This video demonstration is created for your understanding of Unitma's Automated Tissue Microarrayer. Unitma has started to develop products to implement tissue microarray technology and completely develop the recipient block, the key to TMA implementation technology, in 2000. Unitma applied for an international patent for a technology that it developed in 2004. It registered the patent in the US in 2006 and in Australia and in Japan in 2009. Unitma completely developed the manual tissue microarrayer in 2006 and now provides it to over 450 hospitals and research institutes around the world. Unitma recently developed the Automated Tissue Microarrayer to offer equipment that implements the most innovative TMA technology to major organizations all over the world. Let's look at Unitma's Automated Tissue Microarrayer. This instrument automatically extracts a tissue sample from the donor block and places it into the recipient block. For this, it uses a Windows XP-based computer as its main controller and has 2 cameras and a 5-axis motion controller built into it. The procedure for Unitma Automated Tissue Microarrayer's extraction and insertion of a tissue sample is as follows. The camera only for donor blocks automatically recognizes an area marked by an oil pen on a donor block to extract a tissue sample. Then the camera moves to a recipient block where the tissue sample will be placed. The camera only for recipient blocks automatically recognizes the center of the hole to compensate the coordinates and to insert the tissue sample. With the cameras, a tissue sample is recognized and the position of the hole where the sample will be placed is identified, so that very accurate work can be done without tolerance. This automation is available only with 3 parameters of TARP, Tissue Array Report Program: the core size, number of donor blocks, and number of tissue samples in each donor block. After this work is finished, the information on the donor block that was inserted into each recipient block hole of the TARP file is renewed and saved. This TARP file in Excel format can be used in various ways. Let me introduce the names and images of this instrument. On the front side are the front door, tray door, touchscreen, and drawer for the keyboard. On the right side are the main power switch, PC power switch, monitor connector, USB connectors, LAN connector, nameplate, and AC power input part. In the instrument are the puncher module, the 1, 2, and 3 mm punchers, camera 1 for the donor blocks, camera 2 for the recipient blocks, LED lighting, the front door sensor, the tray door sensor, the main plate, the donor block tray, and the recipient block tray. The instrument part is composed of 5 axes. To easily move the puncher module in a 3D space, 3 axes are needed. With the main plate on the Y-axis, the donor block and recipient block trays can be unloaded, and the structure is also applied when the puncher module is used. On the left and right sides of the puncher module are the cameras for the donor blocks and the recipient blocks. Under the cameras, LED lighting is built in to allow the cameras to recognize the targets correctly. In other words, in the instrument part are 5-step motors, 3 linear motion guides, the main plate, and 2 cameras. The control part is based on a commercial computer. It has a 5-axis motion controller, a stepping motor, an I/O module, and 2 cameras. The cameras and the touchscreen are connected via a USB. UATM.exe, the software used in this instrument, is a Windows XP-based program. Basically, it offers a touchscreen user interface and has 4 menus. Demo is the demonstration mode that shows the work that is the same as the actual operation status. The work of extracting and inserting a tissue sample is displayed via simulation. With this demo, a user can briefly identify the operation of this instrument. Auto is the auto operation mode, which extracts a tissue sample in the donor block and delivers it into the recipient block. The work information is saved in the TARP file in the Excel format. The work report is also saved in the TARP file. Set allows calculation of the camera's resolution, setting of a threshold value, and saving of the main setting values for the instrument operation, such as the mechanical origin and distance. Exit ends the program and returns to Windows. The cassette in which a tissue sample is molded with paraffin and standardized is called a donor block. The user marks an area to be extracted in the donor block with an oil pan and dries the ink for at least 2 hours to mount it into the donor block tray. The donor block tray can accept up to 10 donor blocks, and it is mounted into the main plate. The recipient block, a patent technology of Unitma, is made up of a special matter that melts if it is heated at 60 degrees Celsius for 30 minutes. Holes are evenly arranged in the rectangular block. It saves the time for making a current block and allows a researcher to maximize the efficiency of the TMA technique. See the one-cycle auto operation. The basic operation of this instrument is divided into 8 steps. First, the camera moves to a donor block. Second, capture a tissue sample image from the donor block. Third, get the coordinates of the sample. Fourth, pick up the sample. Fifth, the camera moves to a recipient block. Sixth, detect the center of the hole of the block. 7th, calibrate the coordinates of the block to move a tip. 8th, insert the sample. The 8 steps are included in one cycle. Let's look at the structure of the software. The software that is used in this instrument is divided into 4 menus: Demo, Auto, Set, and Exit. Demo displays this instrument's auto operation. Auto extracts a tissue sample in the donor block and inserts it into the recipient block according to the TARP program. Set sets the values that are necessary for the operation, such as the calibration values. Exit ends the program. The Tissue Array Report program, TARP, is in Excel format and has 3 setting values: the core size, punch count, and sample count for the operation of this instrument. After a task, this file holds the information on the finished recipient block in each hole. The TARP file contains 2 parts. One is for entering information to DirectWorks, and the other is for printing or exporting work results. You can use 4 operation methods in this instrument. Auto automatically moves a tissue sample from a donor block to a recipient block. For auto movement, Programming should be done. Programming is very simple. Just set 3 parameter values: the punch size, the number of punches in each donor block, and the number of donor blocks in an Excel file offered by Unitma. The file with the 3 parameter values is called the TARP file. Remember the marking on the target area to extract the sample tissue from the donor block. Let's start the auto operation. Turn the power on. The lamp turns on and the computer starts booting. Press Auto on the touch screen. Press Load File. The File menu screen is displayed. Select the TARP file created. Press Initialize. The absolute origin of the initialization, where the X, Y, and Z axes of the coordinates in a 3D space are 0. 0 and 0 is very important. It is the base point of the space recognition. Prepare donor block and recipient block and mount them. Be careful when marking the donor block. Mount the marked donor block onto the tray. Press Set Tray to put the donor block tray and the recipient into the main body. The stage comes out. Mount the donor block tray onto the stage. Mount the recipient block onto the stage. Press Start to start the auto operation. The tip makes a directional mark on the corner of the recipient block. First, the camera moves to a donor block. Second, acquire a donor block image. Third, calculate the coordinates of the donor block tissue sample. Fourth, pick up the sample using a tip. Fifth, the camera moves to a recipient block. Sixth, detect the center of the corresponding recipient block hole. Seventh, move to the calibrated coordinates of the block. Eighth, insert the tissue sample. Repeat the 8 steps until the process is completed. Menu manually moves a tissue sample from a donor block to a recipient block. Teach is activated only during the auto operation. This occurs when the search for a tissue sample in a donor block fails or when the search for a recipient block hole fails. There are menus for each donor block and recipient block. Demo mode displays all the steps from the extraction of a tissue sample from a donor block to its delivery to a recipient block for you to understand this instrument. Setup indicates the setting of the physical positions of the 2 vision recognition cameras, 5-axis motion controller, starting point sensor, donor block, recipient block module, and each component, and the setting of the constants and variables that affect the camera image processing.